All right, today we're going to learn how to graph exponentials. So we're going to start off with a basic one, y equals 3 to the x power. For our x powers, we're going to use things like -2, -1, 0, 1, and 2. Occasionally, we'll be able to fit 3 and -3, but we'll look at that later. So let's start with the positive powers. What's 3 to the 0 power? It's 1. 3 to the first is 3, and 3 squared is 9. The negative exponents will take the reciprocals of these. So since 3 to the first is 3, 3 to the -1 would be 1/3, and 3 to the -2 would be 1/9. Now those are pretty hard to graph. We're just going to do our best. For these, they all have horizontal asymptotes, so it's going to be y equals, and for this one it's going to be y equals 0. Now we'll come back and do domain, range, and behavior, and the increasing and decreasing at the end. So -2, 1/9, -1, 1/3, 0, 1, 1, 3, and 2, 9 won't fit, so we'll just leave it off our graph. So it's going to go like this. It's never going to touch y equals 0 because even if we raise it to more and more negative powers, it's going to get just smaller and smaller fractions. It's never actually going to touch 0. So for our domain, we've got an arrow on the left and an arrow on the right, so our domain is from -infinity to infinity. And our range is never going to touch 0, so we're going to use a parenthesis. It starts close to 0 and goes on to infinity. If you wanted to use set notation instead, you could do x such that we know all of these values are bigger than 0, so it would be x is greater than 0. You can use whichever form you'd like, it's your preference. Now, is this function increasing or decreasing? If we start on the left and move to the right, it's going up, so it's increasing, and it's increasing the entire time, so it's -infinity to infinity for our increasing or decreasing interval. And our end behavior, as x goes to +infinity and as x goes to -infinity, f of x goes to, our arrow on the right is pointing up, so it's going towards +infinity, and our arrow on the left is getting closer and closer to our asymptote, so it's going towards 0. In number 2, we have a base of 1/2. We're still going to use the same x values, x to the -2, -1, 0, 1, and 2. Any base to the 0 power is going to equal 1. Any base to the first power is going to be the base. When squaring a fraction, you square the top and you square the bottom, so that would be 1/4. If we raise it to the -1 power, it's going to be the reciprocal of the first power, so this would become 2. And the -2 power would be the reciprocal of the squared, so this would be 4. Our asymptote is still going to be at y equals 0. Let's draw that in. And let's graph these. -2, 4. -1, 2. 0, 1. 1, 1/2. And 2, 1/4. Now I came pretty close there. Let's try. You want to always try and make sure that your graph does not touch your asymptote. So domain, we still have an arrow on the left and an arrow on the right, so our domain is -infinity to infinity. Our range is everything above 0, so 0 to infinity. Remember to do a parenthesis because we can't touch the asymptote. This interval, if we start on the left and move to the right, it's always decreasing, and it's decreasing everywhere. so negative infinity to infinity. Then our end behavior, as x goes to positive infinity, f of x goes to, and as x goes to negative infinity, f of x goes to. Our arrow on the right, this time is the one getting closer to the asymptote, and our one on the left is going towards positive infinity. Now let's look at one that's got a little more going on. Here, our base is 3. And that's going to help us make our xy chart. Our h is going to come from the exponent, so it'll be -1. And then our k is the number on the end, so -2. Since our base is 3, we're still going to use -2, -1, 0, 1, and 2. And we're going to raise 3 to these exponents, which we did in the first problem. So 1/9, 1/3, 1, 3, and 9. Since this k value is going to shift our graph down 2 units, our asymptote is going to move down 2 units and become y equals -2. We're also going to sketch in h equals -1 to help us graph. Our domain is still going to be negative infinity to infinity. And since our graph shifted down 2, so did our range. So that's now going to go from -2 to infinity. So let's now plot our points. We're going to plot our x and y values from where our h and k moved our graph. So from here, -2, 1/9, -9, or sorry, -1, 1/3, 0, 1, 1, 3, and let's see if we have space for 2, 9, 2, 1, 2, 3, 4, 5, 6. It only goes up to 7, so it'll cross right about there. We'll use that to help us guide our curve. Close enough. So what is this graph doing the whole time? It's increasing from negative infinity to infinity. And let's write our end behavior. On the right, our arrow is going up. And on the left, it's going towards our asymptote, which is at -2. Now let's look at one that has an a value. So here, a equals -2. Our base is the 3, h is -1, and k is -2. So our asymptote's still at -2. Remember, that's going to match up with our k. Our chart is still going to be based off the base of 3. Domain is always going to be negative infinity to infinity. Now, because of this a value of -2, just like all the other functions, we have to multiply that with our y's. So we get -2/9, -2/3, -2, -6, and -18. I'm going to sketch in our h equals -1 to help with our graphing. So from our h and k spot, we're going to go left 2 and down 2/9, left 1 and down 2/3, 0, -2, and it's going to go off a bit, but 1, -6. So it now curves like this. So our range this time, since our arrow is pointing down, will be from -infinity, and then it'll still stop at our asymptote of -2. As we move from left to right, this is decreasing the entire time. And end behavior. As x goes to positive infinity, f of x goes to, and as x goes to negative infinity, f of x goes to. Our arrow on the right is going down, so -infinity, and our arrow on the left is going towards our asymptote. Now, what if we needed to match up the equation with a graph? We know that this graph is shifted down 4. So that means k has to equal -4. Luckily, we have options here, and they made it pretty easy. Which one of these equations has a k value of -4? That would be D. One last thing we're going to talk about is, are these graphs growths, decays, or neither? So let's go back to our first example. If you looked at this graph, would you say this graph is growing or decaying? As we moved from left to right, it goes up, so this one is a growth function. In number 2, as we move from left to right, it goes down, so this is a decay function. Number 3, although we shifted it down, as we move to left and right, it grows, so this is a growth function. And number 4, this one's flipped upside down. It's neither a growth nor a decay. So to summarize, well, this one is also a growth. The way to determine if it's a growth or decay is based on the base. It's a growth if the base is greater than 1. It's a decay if the base is less than 1. And it's neither if you have an A that's negative.